The Constitution of India. Preamble. We, the people of India, having solemnly resolved to constitute India into a sovereign, socialist, secular, democratic republic and to secure to all its citizens justice, social, economic and political, liberty of thought, expression, belief, faith and worship, equality of status and of opportunity, and to promote among them all fraternity, assuring the dignity of the individual and the unity and integrity of the nation. In our Constituent Assembly, this 26th day of November 1949, do hereby adopt, enact and give to ourselves this Constitution.
Happy morning, students. I know you all must be energetic now because just finished our sports day and we had a wonderful 2 days time spending with all our 12th standard students, both science and commerce. Teachers were so surprised that those children whom we have not imagined to be on the ground were just running on the field. So thanks to our school management principal sir for giving us a wonderful post-COVID 2021 where we could have fun. We enjoyed a lot on those 2 days of time. Now let us get back into academics. I know you people are preparing for your improvement exams. Do it on the side. Prepare yourself a timetable so that you get on with your good marks. I know you will do the best, children. So today we are going to start a new chapter, coordination compounds. Before getting into the topic, I just want to share a small story here. Once there were two friends who were walking in the desert. Meanwhile, when they were walking, they were into an argument. At the end of the argument, one of the friend slapped the other. So the friend who got the slap immediately wrote on the sand stating, "Today my best friend slapped me." And after some time they started walking. Where they reached an oasis, they decided to take bath, and the friend who got the slap got stuck into the mire and was about to drown, where the other friend helped him and saved him. So this friend who got the slap immediately went to a stone and wrote on the stone stating that, "Today my best friend saved my life." So this friend who slapped him and saved him asked his friend, "See, when I slapped you, you wrote on the sand and now you write on a stone. What does it mean?" So this friend who had been slapped told him, "My dear friend, when someone hurts you, you should always write on the sand so that the wind of forgiveness will erase it away. And when someone does good for you, it should always be engraved, so we should write on the stone so that no wind can erase it." So the moral that we learn from this story is that, children, do not value the things that we get from others. Instead, value the person that you earn in your life. Earning people is more important than earning things. So the more good friends, the more good people that you earn in your life, give value for them, right? So with this, we'll start the first class of the new chapter, coordination compounds. We'll see what are coordination compounds. Alfred Werner was a scientist who proposed the theory of coordination compounds. The compounds which tend to be coordinated, means joined. So where he was doing several experiments and he came to a conclusion that there is a central metal atom or an ion which has got two types of valency, namely primary and secondary valency. Definitely we will be learning about each and every fact what it is. So he did an experiment with cobalt-3 chloride. In that experiment, cobalt-3 chloride was dissolved in ammonia, where the chloride ions start getting precipitated as silver chloride when silver nitrate is being added to the solution. So, if you see cobalt 3 chloride with 6 moles of ammonia is yellow in color, which is giving 3 moles of silver chloride on precipitation. That is, with 3 Cl3, all the 3 getting precipitated. But what happens? The same thing which is with 5 NH3, you can see 2 moles of AgCl getting precipitated, and here both the compound having same formula but different characteristic properties because of the color they bear. So, here each of them precipitating 1 mole of silver chloride. Now, what did he learn in this is that there are some groups which are being entitled into a square brackets, and there are some groups which are outside the square brackets. So, those atoms or group which are inside the square brackets cannot be dissociated or will not get dissolved in water or will not get ionized. Those which are present outside the brackets will tend to get dissolved in the solution. So, this is what we will be learning in coordination compounds. So, before learning one by one, let us first learn the postulates of coordination, that is Werner's theory. Then we will learn about what is a square bracket, what is a central metal atom, what are primary valency, what are secondary valency, what are neutral molecules, what are negative ions, what are ligands. Okay children, so are you all ready? So, we will learn about the postulates of Werner's theory. Now learn the postulates of Werner theory. The first postulate says that metals have 2 types of linkages. Basically, metals have 2 types of linkages. They are the primary linkage and the secondary linkage. Also, we can name them as primary or secondary valency. And what are this primary valency? Primary valencies are ionizable and they are formed by the negative ions. Primary valencies are ionizable and they are formed by the negative ions. Secondary valencies are non-ionizable and they are formed by negative ions or the neutral molecules. So, either the neutral molecules or the negative ions can form the secondary linkage. This secondary valency is responsible for the coordination number of the central metal atom. That is, this number of secondary valency refers to the coordination number. The next one is the ions or the groups which are formed by the secondary linkage, which are attached to the metal directly. They form different spatial arrangement. That is, they can form tetrahedral shape, they can form octahedral shape, they can form bipyramidal shape. So, they have different spatial arrangement depending on the number of coordination number. So, if you take an example, this is a coordination compound where you have cobalt, which is called as a central metal ion. You have 6 molecules of ammonia which is directly bonded to cobalt. So, this is called as a secondary valency. So, the coordination number is 6. There are 6 ammonia molecules which are directly bonded to cobalt. So, they are called as a secondary valency. And you have outside the bracket 1 chloride ion which is called as a counter ion and which is the primary valency that gets ionizable. Say I put this whole complex into the solution, this does not get dissociate, this does not get break up, only this chloride ion will dissolve in the solution and can come out as a precipitate. So, these are non-ionizable, that is ammonia, and this is ionizable. So, we have 1 primary valency and 6 secondary valency. And this whole square bracket we call it as a coordination entity. Now, you would have learnt about double salt and complex. Double salt are compounds which are formed by the combination of 2-3 stable salts like potash alum, where 2-3 salts are mixed together and they can dissociate or break into its ions. But when I take a complex, it does not get dissociate into its particular ions. That is the only difference between double salt and complex. So, now we will learn much more about coordination compounds. We will learn about one entity, that is what all the things that are present in a coordination compound. So with the beginning, let us start with a coordination entity. What is coordination entity? It is a complex where the central metal atom or ion is bonded to a fixed number of molecules. So the central metal atom is bonded to a fixed number of molecules. You call it as a coordination entity. If you see here, iron has got 6 cyanide ions with a 4- charge. Don't worry about this charge and all, I will be explaining you later. So this is called as a coordination entity, where it has a central metal atom which is bonded to a fixed number of ions or molecules. Similarly here, cobalt is a central metal atom which is bonded to 6 ammonia molecules. So this whole complex we call it as a coordination entity. Now if you come to the next one, we call it as a central atom or central metal atom or ion. It is an atom or ion to which fixed number of molecules, that is fixed number of ions or groups getting bonded, which forms a geometrical arrangement around the central metal atom. So central metal atom is nothing but the atom to which there are fixed number of molecules which are getting bonded, and that gives a spatial arrangement, a particular geometry around the atom. You call that atom as a central atom or an ion. If you take an example with nickel, 2 chloride ions and 4 water molecules, nickel behaves as a central metal atom. Here iron as a central metal atom, cobalt as a central metal atom. So this central metal atom, since it can accept ions or groups, we call them as Lewis acid. Now we will go to the most important part of this coordination compounds, which are called as ligands. Now what are ligands? Ligands are ions or molecules which are getting bonded to the central metal atom. Ions or molecules which are directly getting bonded to the central metal atom. Now these ligands can be simple ions like chloride and bromide. They can be small molecules like water and ammonia. They can be large molecules like ethylene diamine, oxalato and other ions. So these are the different type of ligands. So here if you see, cyanide is a simple ion which is getting bonded to the central metal atom. So this is called as my ligand. Here ammonia, which is a small molecule, a neutral molecule which is getting attached to the central metal atom. So here this will behave as my ligand. So these ligands can be unidentate, didentate, polydentate. What does it mean? Unidentate, uni means one. So there will be only a single donor. Only that particular ion will be donating to the central metal atom. So that example I have written as chloride. Didentate, didentate means 2 donors are there. I have written the example oxalato, where carbon can also donate, oxygen can also donate. You can take ethylene diamine. Here nitrogen can also donate, carbon can also donate. So these are examples for didentate. What do you mean by polydentate? Poly means several, multiple. So there are more than 2 donors, you call them as polydentate. There are several donors. Here I have written nitrogen with CH2, CH2, NH2 thrice. So there are several atoms which can donate to the central metal atom. There is an important ligand which commonly that they ask in the exam is EDTA 2-, which is called as hexadentate. Hexa means 6. You have 6 donor atoms. EDTA full expansion goes like this: ethylene diamine tetraacetate ion. I repeat, ethylene diamine tetraacetate ion. So here EDTA has got 6 atoms which can donate and get bonded to the central atom. And next you have 2 or more donor atoms. Any polydentate ion which has got 2 or more donor atoms, you call it as a chelate ligand. You call it as a chelate ligand. The best example I can give is ambidentate, which is NO2 minus and SCN minus. See, last year we have studied about ambident nucleophiles. Ambident means the same group has got 2 donor atoms. You call it as a ambidentate. So here you have nitrogen also acting as a donor atom, oxygen also acting as a donor atom. Similarly in SCN, if you see SCN, sulfur also donate and nitrogen also donate. So here you call them as an ambidentate ligands. With this coordination entity, central metal atom, ligands are getting over. We still have to learn coordination number. So we will be learning about that. Now we are going to learn about classification of ligands. Ligands are ions or neutral molecules that have bonded to a central metal atom or ion in a coordination complex. A ligand can be an atom or molecule that is a Lewis base, also referred to as an electron pair donor. Each ligand will donate an electron to the central metal atom and form coordinate bond. Water, ammonia and carbon monoxide are called as neutral ligands. And you have simple ions like cyanide, chloride and hydroxide called as negative ions. Depending on the type of donor atoms, the ligand can be classified as monodentate ligand, didentate ligand and polydentate ligand. Now let us see how does it work. In a central atom, we have water molecules attached where there are oxygen atoms. This water molecule is referred as aqua and hexa-aqua aluminium complex ion, aluminium being the central atom, and this water molecules will be coordinated to the aluminium through the oxygen atom, where each oxygen atom donate an electron to the central metal atom aluminium and form coordinate covalent bond. Here the donor atom is 1, so it is monodentate or unidentate, as only one electron is being donated. Bidentate ligands will have 2 lone pair of electrons that binds to the central atom. You have 1,2-diaminoethane, where there are 2 nitrogen atoms each having a lone pair of electron which is being donated to the central metal atom. So since there are 2 nitrogen atoms giving 2 lone pairs, you call it as didentate. And you have diethylene triamine, where there are 3 nitrogen atoms, each nitrogen atom possessing a lone pair of electrons which is being donated to the central atom, forming a coordinate covalent bond which refers to as tridentate ligand, as there are 3 lone pair of electrons being donated. So the ligands are more important and they are ions or neutral molecules bonded to the central metal atom or ion in a coordination complex. Based on their attachment to the metal, ligands can be classified as one of the 3 types: monodentate, didentate and polydentate. A ligand with only one type of donor atom bonded to the central metal atom is referred as monodentate ligand. We'll get back into the next topic, that is coordination number. Coordination number refers to number of ligands, that is the number of donor atoms which are bonded to the central metal atom directly. That we call them as a coordination number. Let's take an example where we have platinum bonded to 6 chloride ions. So 6 refers to the secondary valency, which is also the coordination number of platinum. Come to the second example, nickel bonded to 4 ammonia molecules. So 4 is the secondary valency Ammonia is a neutral molecule which acts as a ligand. So, the coordination number of nickel is 4. If you come to another example where we have iron bonded to 3 oxalato ions and copper bonding to 3 ethylene diamine ions, where I have written the coordination number of iron and cobalt is 6. But if you see the structure, we have only 3 oxalato ions and 3 ethylene diamine ions. But why the coordination number is 6? Because both oxalato and ethylene diamine, short form we write it as EN, both ethylene diamine and oxalato, they behave as bidentate ligands, that is they have 2 donor atoms. So, 3 into 2 becomes 6. So, I have 6 as the secondary valency, also called as a coordination number of iron. Same goes here, En is a 2 donor molecule, or I will say bidentate ligand. So, the coordination number is 6 because the secondary valency of iron, or here its cobalt, is also 6. So, this is called as a coordination number. What is a coordination sphere? Coordination sphere, we have a square bracket which we call it as a coordination entity, where we have the central metal atom getting bonded to the ligand directly, where the ligand can be a negative ion or a neutral molecule. So, we have here cobalt getting bonded to 6 ammonia molecules. 6 ammonia molecules means I know the coordination number or the secondary valency of cobalt is 6. So, this whole set we call it as a coordination entity. And what is this? These are ionizable negative ions which are called as a primary valency. So, I have 3 chloride ions. So, the primary valency is 3, and any ion that is present outside the square bracket are called as primary valency, or also they are called as ionizable valency, and the name we call them as counter ions. So, these are my coordination entity and this is my counter ions. The whole set I call it as a coordination sphere. And what is the next topic? We are going to see about coordination polyhedron. What do you mean by that? Depending on the number of ligands, that is the ligands are responsible for the coordination number. Now these ligands, it can be 2, 3, 4, 5, 6. So these ligands, when they are bonded to the central metal atom directly, they gives out a spatial arrangement. Spatial arrangement in the sense they form a geometrical shape around the central metal atom. So we know when there are 6 coordination number, it refers to octahedral. If they are 4, it refers to square planar. If they are 4, again it can be a tetrahedral also. It can be 5, which is trigonal bipyramidal. So depending on the spatial arrangement of ligands which is bonded to the central metal atom, gives them a geometrical shape depending on the coordination number of the central metal atom or ion. This we call it as a coordination polyhedron. Now you can refer to the page 241 for better understanding of the shapes of the coordination sphere. The next one is the oxidation number. We used to write the oxidation number of the central metal atom to understand how many ions it is lost or it is gained. Charge carried by the central metal atom, if all the ligands are removed along with the electron pairs that are shared, when all the ligands are removed, what is the charge that the central metal atom carry? That we call it as the oxidation number. Now let us take an example here, copper having 4 cyanide ions. I know the value, that is the oxidation state of cyanide is -1. So minus 1 into 4 is -4. So X is for copper, X plus -4 is equal to -3, which is the charge of the sphere. So -4, when it goes on the other side, it becomes +4. So +4 minus 3 will become +1. which is the oxidation number of the central metal atom copper. So we will be doing some more examples to find out the oxidation state. So do not worry about it. The last topic is homoleptic and heteroleptic. Homoleptic means the central metal atom which has got only one kind of donor group. There is only one donor group. Like for examples, I can take like this, platinum having 6 chloride ions, there is only one donor group. Heteroleptic means there can be 2 or 3 donor groups with the central metal atom. So here along with chlorine, if I put ammonia here also, both chloride and ammonia are bonded to platinum, but it is not only chloride or not only ammonia. If chloride alone is present inside the bracket, it is a homoleptic coordination complex. If I have both chloride and ammonia, more than one kind of donor atom, it is called as heteroleptic complex. I hope you understood all the basics of coordination compounds. The next topic is a little bit easy actually and definite question for the board, which is the naming of the coordination compounds, which we'll be seeing in the next class, okay, with different examples. I'll try to include some videos if possible. Because of this time lag issue, I couldn't upload it, children. So definitely I'll see to it that today with reference to this topic, if I could upload, I'll do that, which will be helping you for better understanding. Okay. So thank you, children. Have a great day. Stay home, stay safe, take care. Bye. So now let us learn about the coordination number and geometry of complexes. In the transition series, there are some of the transition metal ions like nickel, cobalt and platinum forms various geometrical complexes depending on the coordination number. The number of ligands directly bonded to the central metal atom gives the coordination number, which affects the geometry of the complexes. There are primarily two geometry which are possible with coordination number 6 and coordination number 4. In coordination number 4 we have tetrahedral and square planar, and 6 we have octahedral. So now let us learn how tetrahedral and square planar complexes are formed. Tetrahedral complex, central atom is connected to 4 substituents and the bond angle formed here is 109.5 degrees. In this, an example is nickel carbonyl, that is tetracarbonyl nickel, where nickel bonded to 4 carbonyl atoms forming a tetrahedral complex. Copper to chloride, each copper where the copper is being connected to 4 chloride ions. We have one more example where vanadium connected to 4 hydrogen forming a square planar complex where all the 4 hydrogens lie one plane. This type of geometry we call it as square planar with a coordination number 4. Nickel, palladium, platinum are some of the complexes or some of the metal ion which form the complexes with square planar. We have cisplatin, an anti-cancer drug which has got 2 chloride ions with 2 ammonia molecules forming a square planar complex where all the 4 atoms occupy the corner positions. And now we will learn about octahedral complexes. You have the central metal atom having a coordination number 6 bonded to 6 ligands, where 4 of the ligands are on the same plane and there are 2 ligands which occupy one above the plane and one below the plane. Let us take an example where molybdenum hexacarbonyl, that is MoCO6, where we have 6 carbonyl atoms, one above, one below, 4 occupying the corners of one plane and molybdenum being the central metal atom. Summary: the transition metal ions form coordinate complexes. The coordination number will affect the geometry of a complex. The coordination number 4 and 6 form the most common complexes in the transition metals. Complexes with coordination number of 4 will exhibit tetrahedral or square planar geometry. Complexes with coordination number of 6 may exhibit octahedral geometry.